The music was good, right?
I know, it's very jazzy.
Yeah. People usually give some minutes for people to join on the live, but I think I can just start, and then if somebody joins, they can just roll back the thing in LinkedIn, and then they will be able to watch it.
Absolutely.
Yeah. So I don't know if anybody watching here, but we're glad to have this last session of 2025, which is a very unique one, and we have a very unique guest, who is David Tippett. David, thank you very much for coming here and for accepting to join us on this very unique talk where we're going to dive into the details of BM25 and search. If you don't know David, then you don't know BM25. If I wanted to put it simple, this is like the thing. But David is somebody who's very generous with his knowledge and someone who defines, I would say, the search engineer in the internet. And that's not I'm not throwing flowers on you, because when you look for the definition of a search engineer, it's very hard to find a definition of that role. So I'm gonna let you tell us a little bit about yourself and tell us about the search engineer and how you see it.
Yeah, for sure. And thank you so much for having me. Like, it's so great to be able to be on and talk. And I think I definitely am a big advocate on the search engineer as a role, as a job description. I feel like it's super underutilized, and I see this at my work all the time. But yeah, I'm David. I am a search engineer at GitHub right now. Honestly, I don't have there are a lot of people in the search engineering industry that have been around for 20, 30 years. I've only been doing search for the last 4 or 5 years at this point. So yeah, I know. I still feel like a rookie, but I think one of the things is once you realize that search engineering is a domain and you start diving in, it's not super challenging, in my opinion, to find yourself pretty deep. There's so much to learn, but there's also a bunch of people who are really cool and willing and able to come out and help you. And also it's a very small, tight-knit community.
Yeah, I mean, one of the things that it gets confused with is search and then research. So when you tell someone who has nothing to do with search, I'm a search engineer, they would think that you are doing some R&D for some other company. Yeah. But it's actually a very unique field where you're trying to optimize the search experience overall. How is it going in the world, or generally that search adoption? Or I watched one of your interviews when you were comparing the Google and not Google environments. So basically search is for Google, the others are trying to catch in or something.
Is that yeah, I think that's a really good way to describe it, because from my perspective, Google has spoiled us so much. People, they go onto Google, they search, and they find exactly what they're looking for. And normally it doesn't take several different tries on Google to go through and do this. And one of the things that I think is really important, the reason that you hire search engineers is for that same level of experience. It takes a lot of time, effort, and engineering to be able to get search to be that easy, so to speak. It takes a lot of work to make it not as much work for your users. So yeah, that's one of those things I'm a big proponent of. And I think the thing is, search engineering is becoming more known. I think, we were talking before about RAG. RAG is becoming really big. Vector search is becoming huge. And I think these are going to be critical to most companies' search tool chain, we'll say. But I think that so many people believe that vector search is it. And, it's going to solve all of our problems. We'll just get vector search and boom, no more engineering for us. It's just vectors. It's just not the case.
Yeah, I think that's an important point that you mentioned there, which is the search came back to the scene thanks to the RAG hype. I mean, everybody is trying to do the RAG, and in RAG, they need to have some context. And in order to get that context, they go in for the search. But they're doing it wrong because they think that the default is vector search. For you, what's the default for you?
The default for me is always BM25. I preach this a lot, and I think this is one of the things is a lot of people get frustrated. because you go in and you start doing like a normal BM25 search, which for those who aren't aware, BM25 stands for Best Match 25, and it's the core search algorithm behind things like OpenSearch, Elasticsearch, Solr. So a lot of these like search data stores, I won't call them databases because I don't believe in that, but search data stores use BM25 to find and score basically documents and then retrieve. And one of the things is, it's like when you first use these search engines, it feels very brittle. You're like, I searched for this and it found nothing. Why? And this is why you hire a search engineer, because a search engineer will be able to go in there and help you and understand, okay, well, you searched for this, but you don't have, you misspelled it and you don't have any spelling correction, no fuzzy. So that's one thing. Or, maybe you search for something and you used a synonym of the actual thing. Well, okay, you need to do some clickstream logging, do some data mining to build these synonym graphs. So there is a lot of work to get like BM25 to what I would call its like best state. But I think when it is in its best state, it is going to outperform, in my opinion, a lot of the vector search, just out of the box.
Was it always done like this? Was it always done by scoring using the BM25, or there was like a historical evolution that brought us to this to the situation that we are in today? And I believe BM25 is an old algorithm.
Yeah.
So there was no better algorithm after that?
So actually there have been a lot of different algorithms. So before BM25 is actually built on top of another algorithm called TF-IDF, which is term frequency inverse document frequency. It sounds like a really big, scary way to describe it. But basically what that stands for is, hey, we count the terms in your query and we count how many times they are in the documents that we've matched it to. And then we see if those are very common terms, are they in every document, which is inverse. So that was another one. It's so funny because I keep getting like going on different talks with people doing like Postgres search and building there. And Postgres uses like this very novel search algorithm, which I can't even remember off the top of my head. I was looking at it and I was like, I have no idea why they did this. Like we have so many like really good information retrieval algorithms and this is none of them. But yeah, so there are a lot of different information retrieval algorithms. BM25 has been one of the standards. I think there is, what is the newest one? There's one slightly newer than BM25. It's like BM25 RF or something like that. And I'm gonna totally botch this.
Is it like an enhanced version of the BM25, or is it like changing the parameters and the coefficients, or is it really a new algorithm that changes the whole nominator and denominator?
No. So it is just a slight enhancement on BM25. So like BM25, a lot of the things that it considers, it considers term frequency, of course, inverse document frequency, which we mentioned before. And then it also begins to do what we call like a discounting score. So like if a word appears like 10 times in a document, maybe, and that document's like 100 words long, that word is pretty important to the scoring of that document. If that word appeared 99 times in a document that is 100 words long, that doesn't give us that much more information. So it also discounts for that, which is normalizing, like the term count for longer and shorter documents. And now I'm gonna stop trying to remember what that addition to BM25 that there is.
Yeah,
you
can mention it later if you remember it.
Yeah.
So before like diving into the technical details of that BM25, you mentioned that people should focus more on the search because it's like the backbone of an application, and mainly in the application that has to do with generative AI, like use cases like RAG.
Yeah.
What do you think you should convince with this? Should you convince the developers, or should you convince like the stakeholders?
This is tough because like I think most of the people building search don't realize that they are in a domain where there is. So, you were talking about the developers and the, stakeholders. I think both of them actually need convincing. So like here's a great example. Like I came into GitHub, and one of the things that I found pretty quickly is the people building most of our search experiences were just software engineers by trade. And when I say just software engineers by trade, I don't want to like diminish these people are incredibly talented software engineers, but they hadn't really built any expertise in search. So they're going through this and they're trying to figure out, how do I determine what is, going into my search experience? And there's a really great example of this where we had an autocomplete experience, and they're like, I can't figure out why this, I type this in and it's not matched. So I started walking them through, here's the explain for Elasticsearch, it has an explain API that tells you exactly why certain results matched. And we went into the explain, we didn't find anything great there. So I was like, all right, let's go and let's look at the index definition and the tokenization. And that's where we realized they were using what's called edge n-grams, which is, for those who don't know, an n-gram is basically a certain number of characters. So they're called grams. And an edge n-gram basically starts at the beginning of a word, moves out some number of characters and saves that as a token, and then adds a character and saves that as a token. So when you build an edge n-gram, and that's the only way it's indexed, if you search for something in the middle of that word, like say I had like a hyphenated word, you can't look up the second half of that hyphenated word. And that's what was happening. And because they didn't have search expertise, they didn't understand that. So this is where it's really challenging, because it's like, a lot of these people that are making these decisions about search, they're like, we need AI search, so vector search it is. And, they've been sold this idea that vector search is just going to solve all of their problems, when it's actually really, really hard to implement.
Yeah, and I think it's also the responsibility of like the software providers, because I feel like the direction they are going in is a direction where they're making their software as plug and play, so you can just plug in it and play, and they're not giving much room for the user to do the analytic side of the. And I think this is what very important thing that you mentioned. For example, the fact that people are using the subword that does not start at the beginning of the word. This is like something analytical that you need to do from your side, but you need to understand the software behind. So when do we start? For example, if we want to do, let's talk about GitHub. GitHub is very, I think that there is something very particular about GitHub. It's technical. It's not like an e-commerce thing or something that is usual. It's very technical. Where do you start even to develop? I mean, if we want to talk about the search experience in GitHub, where do you start?
Yeah, actually, this is so funny, because for those who have watched other interviews that I've been on,
I watched all of them.
it's funny because, like, coming into GitHub, I had this expectation. I'm like, it's a software company. Like, their search is going to be super cool, very technically advanced, and in a lot of ways, it really is. Like, actually, there have been a handful of things where I've like sat and watched what should have taken down our cluster, not, because we had a handful of really mature mechanisms for rate limiting or for throttling or for all of these different things, all of these different mechanisms to protect our search, which is really cool. And then in some other ways, I'm like, this is so incredibly basic. And I will say that's kind of a good thing. Like, I think, when you go to look at, adopting vector search at scale, awful. It's expensive because, every single test you have to do costs real GPU time, and that you have to pay a premium for that. So then, querying vector indexes, tuning them, it's really challenging. So this is why I kind of like BM25, because it is, as far as it goes, relatively cheap to maintain and relatively straightforward to understand once you understand how it works. Now, that's not to say we don't have our own challenges with this. We have some really big indexes at GitHub.
Give us a number.
I'll give a range. We have indexes in the range of tens to hundreds of terabytes.
Wow. Per
And-
index.
And exactly for a single index.
How many shards is that?
You know, how many shards should it be? Maybe. No, this has been another thing is, you know, when you're dealing with things at this scale, you have to start like really checking and making sure your assumptions are right. Because we'll say, for example, the 100 terabyte, maybe approximately that index. Normally, you would say, hey, we have 100 terabytes. We recommend 50 gigabytes per shard.
Yeah.
That's a lot of shards, right?
Yeah,
so this is where, you know, GitHub has, you know, kind of taken and said, does it need to be that? And, you know, we're playing around a lot with like right sizing of our shards. So, you know, we have shards that are well over 100 gigabytes, which is good in the sense that, you know, it's much less shard maintenance we have to do, but it's also bad because, you know, potentially we could spend a lot of time searching one shard. So yeah, this is where I say, you know, BM25 is more straightforward, we'll say though, because a lot of these are known, what's the word for that? Known parameters. You know, kind of the different parameters that you can tune. You can tune how large a shard is. There's really good tooling around it. So I can use, Elasticsearch has a profile API. So I can run a query and I can say exactly how much time it spent on each shard and which shards spent the most amount of time, which portion of the query did it spend the most amount of time on. And there isn't that same level of maturity and tooling right now for vector search, as far as I've seen. Things are
is it like a try catch? So you just make the size bigger and then you test it, or there is like a methodology behind it?
You know, I'd love to say that we have a really great methodology. We're not quite there yet. Excuse me. So yeah, we're still working on a lot of this, but all that to say, this all existed for years and years before I got there. And, you know, it's just remarkable that GitHub search has remained up and stable using just BM25. Now, there are some recommendations that I have, you know, one of the things that we've found, and of course, many people find as well, is routing has been crucial to GitHub. What I mean by routing, for those who aren't aware, Elasticsearch has, and OpenSearch, and probably Solr as well, has ways to use a routing key to route a query to a single shard or potentially several shards, so that that query is only hitting exactly the shards with the data that it needs. So an example of this might be, you know, like you are looking for an issue and you're looking for an issue that exists on a repo. So long as we know what repo we're looking in, finding that issue is very straightforward. We'll use the repo ID as the routing key. That'll bring us right to the shard that has the information that you're looking for. Now, if we take that routing key away and we issue that same issue search, that's expensive. You are looking against potentially all the shards on, you know, in GitHub search. So routing has been crucial. And actually, just a couple weeks ago, my coworker was looking into one of our indexes and had found that the routing key wasn't included in the search. And it was a very straightforward fix. He had it out in a day, and that cluster went down in utilization by 4,000. I mean, it's wild. And this is the thing, is like, you know, my team, we're small. We have, I think, 5 engineers right now. And we really manage Elasticsearch more as a platform inside of GitHub. We don't do all of the search and all of the queries and all of these things. We act as kind of a resource. But this is where I'm like, you need more people with search expertise in your company, because, or every company does, because those types of things could be costing you a fortune in infrastructure.
You've talked about the software side here, about how you organize the shards, the indices, etc. I have a couple of questions about that, but I wanted also to touch on the infrastructure.
Yeah.
What is the hardware that you have behind? Is it like bare metal? What are you?
Yeah. So we're running a lot of GitHub search runs on Azure VMs. We have a bunch of actually different instance types that we use at any point in time, which we're working on consolidating. But the hard part is the biggest bottleneck for GitHub search isn't CPU, it isn't memory. It almost always comes down to IOPS for disk. And sometimes the only way we could get the IOPS that we needed for reading and writing 2 disks is to use really large instance sizes. And that, it's great because, we can get really, really high, IOPS on those instances, but then we're super underutilized on memory, super underutilized on CPU. I'll actually never forget, there was a time where we were having an issue. I think this was actually a public incident where people weren't being able to load their issues. And I was looking at the cluster. I'm like, the CPU on this cluster is not, is no problem. We have plenty of CPU. We have plenty of memory available. Like it took a lot of digging in for us to realize that the issue was actually we just weren't able to get through all the queries fast enough. Because of miscellaneous different things like thread pools and the thread pool queue sizes, which has actually led to probably one of the longest standing bugs, which I still have yet to fix. But I'm not gonna dive too much into that one.
We're not live, you can say it.
Yeah, it's true. It's true.
When you say the IO, does that mean that like you have too much indexing and too much reading at the same time?
Yeah, we have a huge amount of indexing happening at any point in time because we made a couple, what's the word for that? We made a couple decisions around how we would do operations for indexes in Elasticsearch. And one of them is every time a document is updated, instead of just doing like a partial update of that document in Elasticsearch, we rewrite the entire document. And we do that to ensure that the document is always the most recent copy, completely up to date. But that's more expensive to do. And
isn't that a default? Like when you do an update, it does not re-index the whole thing?
Hold on. Maybe I'm wrong. Maybe no, there are partial updates. Like we could do, the like partial updating for documents. But maybe, I think you're right though. It is default, but we send the whole document through every time rather than just updating the fields. I guess that's the point that I'm making.
Okay.
But yeah, and we've made like a lot of decisions about like how we do index operations. So, we've have our own reindexing process that reads from MySQL, and if we need to reindex an index, we pull the entire thing from MySQL and put it in. And we've been trying to adopt some of Elastic's tooling for this, like Elasticsearch's native reindex, and it doesn't work at our scale. It just falls over, and we're trying to work with Elastic to try and get that resolved, but it's challenging because I think when it comes to indexes, we keep everything in hot, so it's tough. Exactly. And all of this makes it operationally pretty straightforward to manage, but then we come with all the other challenges of having indexes that long.
Yeah, with all the functionalities that are offered with Elastic, like throws and all stuff, using the hot feels like you are only scratching the surface of Elastic. It feels bad from like your experience with the stack.
Yeah, actually, and this is something we keep talking about and we keep bringing up, but it's just incredibly challenging because, at the end of the day, you could go back into any point in history and reopen an issue. And then all of a sudden we've got to find some way to, okay, now how do we reflect that in Elasticsearch? Like how do we offload to a cold tier when anything at any point could be updated?
Is that something that is doable in search use cases? I mean, even outside of like GitHub, do people have like those tiers in normal search cases?
Like a hot, warm, and cold tier?
Yeah.
Yeah. A lot of companies do. And actually, I mean, we've talked about, doing that at GitHub and what that would look like. And it just would be, it's a lot of orchestration because what we would eventually do is, if we were to do it, we would probably separate into like a hot tier and a warm tier, where the hot tier would be, data that's been updated, created within the last year. Warm tier would be things like over a year old. But then, once you've done that, so great, you've offloaded onto some cheaper hardware. Then, okay, a document gets updated that was moved onto your warm or your cold tier. Well, now you've got to have some process to go pluck it from there and put it back into hot tier. And that's just, it's one of those things that is operationally very complex.
I mean, when I think about it, if I'm a user, I'm the end user, and they have like the search bar and they have the filters, I would want to get like anything I type from the hot because I want it to be very fast.
Yeah.
But if I'm using the filters, I can wait. I'm expecting some wait time, and I think are those like the details you look at when you're deploying or when you're thinking the architecture of the search?
Yeah, actually, and that comes back to why you need someone with search expertise, is because you need an engineer that knows, hey, there are users that are out there searching, they have some goals, and we need to do our best to match their goals to what it is we're doing at the moment. And actually, there's another really great example of this, and this is where we just recently built and rolled out a query classifier internally. And this query classifier.
What is a query classifier? Can
Yeah.
you explain?
Okay. Yeah. So it's super straightforward, and actually, I have to thank what is it, Doug Turnbull and Jiaming, who just rewrote a GitHub repo search on his own. He scraped all of our public repos, rebuilt it. It's actually fantastic. But so a query classifier is a way to determine user intent for the query. So for this example, what it was users say looked up sort descending. They're sorting commits descending. So I could say that when you sort descending, you're looking for the oldest commit. And one of the things that I did was I wrote a simple rule that said, hey, if someone does sort descending, they're probably looking for old stuff. So I classified it as looking for old commits or something like that. And then one of the reasons that people were having problems with this was because we had a query part parameter filter. What is the word for that? I'm so terrible with words. This is terrible. Basically, we were devaluing older. We had a function score on committer date, and older commits were getting their score decreased because they were older. I'm like, okay, but if you sort descending, they are the most important. So we need to flip that. We need to say, hey, older commits are actually the most valuable. So what we did was, we created this classification rule that says, hey, when someone does sort descending, we need to drop this part off, and we need to consider old commits just as much as. So yeah, this was just one of those little like user experience things that we had to find out because someone told us they can't find old commits. I was like, that's a bummer. Let's fix that. And yeah, this is so like a query classifier is like a really great example of just like a little bit of search engineering tooling that you need at a lot of different companies, and why I think it's so important to start and iterate on BM25, because a lot of people think vector search is just going to solve things, and it's not. You still need all of these different components to make search good.
Okay, so staying at the BM25, how do you use it? So I think here that we are talking about BM25, so we are talking only about like full text search.
Yeah.
Does that mean when you, for example, look for a repo and someone is typing on their search bar?
Yeah.
What information are you? I mean, first of all, the autocompletion. What are you checking the autocompletion again? So are you indexing the whole thing as a document? All document something, or it's by field and then you're doing the score of the fields? How does the query look like?
Yeah.
The length of the query, how many columns does it spread to?
Yeah, no, that's a good point. We have a pretty straightforward data model, so we only have, most of our indexes have anywhere between like 15 to 30 different fields. Most of those fields are like, we have, like for a repo, we'll say you have the repo name, of course, repo description. You have the README, you have the author of the repo. So like these are all the different like types of fields that we add to documents that make them searchable and filterable within Elastic. And all of we do this on all of our different documents where, you know, like we have the plain text, we'll say text filterable things on that document. Now this gets challenging. Like there's also this I wish there was a better like shared data type in Elasticsearch. It would be really nice if we could have, you know, for example, a label. You know, a label might exist on 100, 1,000, 10,000 different issues. And if you have to update that label, you have to visit every single issue and update it on all of them. So yeah, these are the types of things that we have made searchable through
But you're trying to make it minimal so that
Yeah.
you can manage it. Okay.
Yeah, absolutely. And I think actually this is like what I would describe as a anti-pattern I've seen at a lot of different places where, you know, they have hundreds or thousands of fields in Elasticsearch. And I'm like, you
But
know, I
they're not leveraged. They're just there. They're just sitting there. You don't use them in the queries.
Exactly. They're not like explicitly calling them out in queries, or maybe they just like make arbitrary queries, and if it matches any of the fields, I'm like, that's useless. You know, it's like the point of having a field is being able to look into that field and say, hey, that provides me some explicit value. You know, whereas if you have so many fields, no one's writing queries against that unless your queries are like super dynamically generated, which you know, I've after a couple indexes that I've seen, I'm like, I know you're not dynamically generating anything.
So for you, everything is static. You're just defining the template and then using it over and over, right?
Yeah, exactly. So we have, really straightforward template. It's all in code, which is nice. And we have like pretty decent like ops around that. So like someone will check in a new template. It will check the template against what's in production. We can, you know, determine if new fields being added and we can just add them, or if we have to do like a reindex and move it to a new index, which we pray and hope we don't have to do.
Yeah. Is it safe to say, from my understanding, that it was the query that dictated the mapping of the index in your case? Or
You know,
was it the other way around?
yeah, actually, it was probably the other way around. So of course, GitHub Search has been around for a long time, so I can't speak too much to its origins because I've only been here for a couple of years at this point. But from what I understand, a lot of how GitHub Search came to be is a reflection of how the other teams do data. So when I say this, what I mean is, you know, at GitHub, I don't own the queries. I actually don't even own the data. We just own the search platform. So like the repos team, they own their own data model, they own their own queries, they own all of these things. And I think they just, you know, created a pretty simple representation of what they had in MySQL, and they moved it into Elasticsearch. As far as what is, you know, like necessary or desirable for tech. We've actually gone and just over these past couple months have been like going through some of these data mappings, and we're like, does anyone have that mapped to a query anywhere? And we're like, no, surprise. So we're, you know, starting to prune fields as far as like, all right, nobody's using this. This isn't a queryable parameter on an issue, so we should not have it in our search index anymore.
Wow.
Excuse me.
Yeah, one of the things that comes into my mind when thinking about GitHub is the GitHub is international. You have hundreds of languages. Yeah. When I think about the search, I tend to think there is language specific because you have tokenizers and sharp filters and all that stuff. And now you just mentioned that you have README. So for example, if I write a README, there is half French, half English, half Japanese. How do you deal with this? What tokenizer do you use? How do you index that? Because at the end of the day, I should be able to mix languages when I type, correct?
Yeah, that would be best case scenario. I will say, like, I think this is one of those areas that GitHub has a lot of work to do. We don't do a super great job right now reflecting the fact that each of our searchers might be searching in a different language, searching in a different what's the word for that? Like it's not just language, it's also like what
Dialect.
yeah, dialect, but also like different expectations of search. Like you have a software engineer is going to search different than a business analyst is going to search different than an engineering manager is going to search different. So there's a lot of work that needs to be done still for search to be much more flexible and supportive of like different languages. And I'll say, especially for like, I feel terrible for the search experience we're delivering right now for, especially those using languages like Chinese, Japanese, Korean, these non-space delimited languages,
Mhm.
because the experience could be much better there now. So I don't have a good answer for you today, unfortunately, but I hopefully we'll have a better answer soon.
Yeah. So I just wanted to check you to the next question, which
Yeah.
is vector search not solving that problem?
So I think vector search could solve that problem. I think the challenge is like when it comes to deploying vector search, you have to be super careful because there's this anticipation that vector search is just going to solve a lot of these issues, but it also comes with a lot of these issues of its own. Like, for example, I think we were just doing some tests a little bit back and we were getting no results back for something that we were like, this most certainly matches, at least a dozen documents. And, vector search is at this scale, it gets really, really challenging. So, like, for those who know, like, vector search uses in Elasticsearch what's called hierarchical navigable small world graphs, HNSW. So
Yeah.
yeah, this graph, and basically what it attempts to do is when you do a search, it basically routes you through this graph to some end node or nodes, and then attempts to find documents that match on those nodes. Now, it could be for whatever reason you ended up in a poorly bucketed, graph endpoint, and the document you're looking for might be mapped somewhere else. I don't know. That's a terrible way to describe it, but basically with as many documents as we have, it gets much, much harder trying to separate and determine, which documents are good matches and which documents are not. And also, that comes with the challenge of we're doing anywhere, yeah, like tens of thousands of queries per second. So, that's a huge volume to have to do embeddings on.
Yeah.
And, that's another challenge is like, how do we get embeddings for all of these? So yeah, I'm not saying that vector search can't solve that. And actually, for a lot of the language stuff, I'm really hopeful that it'll provide a much better experience. But it's one of those things that we just have to be super careful about, because also like it can return just total garbage,
Correct.
especially for like the 2-word queries. Like it doesn't know what to do.
Yeah. I mean, when it's like in more like technical field, it's hard to make it go. I mean, when it's commerce, for example, give me something that would make me feel good or something like this, then the
Yeah.
intent is kind of clear.
Yeah.
But when you are in a technical field and you're typing so some like code or something, that it will be hard to get the intent from, or to infer the intent from the words, which will make it harder to get the good
Yeah.
vector that would lay in a good, as you say, graph that will drive you or get you to the right documents.
Yeah.
You mentioned one thing that is important, which is like when you're doing lexical search, you're just going ahead and directly typing on that Lucene instance and you're trying to get a document. When you're doing the vector
Yeah.
search, you have another bottleneck, which is the embedding model that
Yeah.
you need to get into, get the vector back, and then you will take that vector and go to the RAM, try to get somewhere where you will land around the vectors that you want. Do you think that the fact that we have vectors on RAM makes up to the time that is wasted on the embedding?
That's a great question.
I mean, yeah, it's another way of saying, is it optimal to use vector search with all the embedding time that you need to wait for, and then the search, and then probably if you make it hybrid, then you would add that.
I think it can be. I think, it's challenging because no matter what, when you are doing vector search, you're adding probably like at a minimum another 20 to 30 milliseconds latency to go and grab that embedding, maybe even up to 100 milliseconds. And that doesn't sound like super much, but when you're talking about a query that should be returning in hopefully under half a second, that can be a significant amount of time. So yeah, I do think having, the vectors in memory is helpful. Also, though, it gets challenging because, for example, for GitHub, we were looking at, the memory requirements for us to roll out vector search to one of our indexes. And we're like, oh, wow, we just need 2.5 more terabytes of RAM and we can hold this all in memory. And, that's a lot. It's a big ask. Do I think it's worth it? Probably in the long term, I think so. But yeah, there's still a lot to figure out there. And also, if, for example, we change models, I think this is a really great example of how challenging vector search can be. We tried a couple different models, and it was just very challenging for us to spend the time waiting for the indexing. And then, try and determine, like, are these results better, worse, where is it worse? Exactly what queries aren't working anymore like we expect them to. And this also comes back to, like, I think that query classifier is going to help us here. I do think, like, there are certain types of queries that I think are much better for, vector search, which is these longer, complete thought type question queries, which we do not handle right now. If you go and type a long question in GitHub search bar, you will probably find nothing. That's a bummer. But, on the flip side, if you do these little 2-3 word queries, that will probably not return you anything meaningful from vector search. So this is where a query classifier could come in and say, hey, this looks like it's a better candidate for a query keyword lexical search versus this other query, which is probably, we should probably route this to a semantic query.
So I think that you're basing, when you're developing this query classifier, you based off your analysis or your algorithm on some evals that you built. How do you, for example, in a company like GitHub, how do you define what the user wants and if they got the right result? And I think there is no thumb up, thumb down in the search. So how do you define that they got the right result they wanted? Or how do you define the relevance?
This comes back to just a healthy reminder to everyone. The people building search at GitHub right now, a lot of them are just software engineers. So we don't have super great measurements around this. And this is one of the things that, I'm trying to advocate for internally is we need to have much better measurements. Now, my thought, my plan, my idea is essentially to use clickstream logs eventually to be able to determine this. So I think we should have, a pretty straightforward scorecard that says, hey, this is the number of 0 result searches that you had. This is the number of, searches where they, rewrote the search several times before they landed on their result. This is, the number of your NDCG scores. We could do live NDCG. I think that would be really helpful. So these are all the things. So right now it's mostly anecdotal. We go out, we talk to customers, we hear, what it is they're struggling with search. And then we try to, build around that, build around their expectations of search. But a lot of that, that's product work, and GitHub is a very product light company. We have a very slim product organization, and a lot of the engineers drive product. So that's one of those places where I'm also looking like, how do we manage this as a platform? As a platform team, can we add tooling to be able to say, hey, all of you, different, engineering groups using search at GitHub, here is tooling that you can use to go ahead and improve that relevance and understand what your users are dealing with.
Yeah, so it's more like you're going for a platform engineer approach where every tool is an API somehow.
Yep.
Uh, yeah. So do you take into consideration that now the users of GitHub are more of agents and application LLM powered applications in your search, or I mean, do you have a way to detect that to account for it, or is it you're just developing for humans and thinking it like a human? I mean, human application somehow.
Yeah, actually, we are thinking much, much more about agents using GitHub as a platform. It's actually incredibly challenging though, because the needs of humans and the needs of agents are so incredibly different. And actually, we found that a lot of agent systems have a really hard time using GitHub search because they don't understand necessarily how to best find results. And I think that's a reflection of a lot of people don't know how to best find results on GitHub.
Yeah.
So yeah, we're definitely starting to think through that. And I think, having people on GitHub side that are working on Copilot as well has been hugely helpful. It's helped us, build a really good understanding. And quite frankly, I think there's a lot of really exciting work coming out of the Copilot group. And I hope that the Elasticsearch group can kind of come alongside them internally to provide a healthy, like, knowledge-based data store that is easily accessible, and performs well at scale. I think is the other part. I think it's really challenging, and we're starting to rethink a lot of the different ways that we do indexing at GitHub. A really great example of this is, for example, I was mentioning routing earlier.
Mhm.
A lot of our indexes right now are routed by repo, but we might in the future go and say we're also going to route by org. Now, for those familiar with Elasticsearch, you can't route by two different keys. So what that means is we're
You gotta
talking
concatenate it too.
not even concatenate. We are talking about potentially duplicating into
Okay.
10 terabyte index, because it's actually, I think it is cheaper for us to spend the money on storage than it is for us to spend the money on expensive compute, because the routing is our biggest challenge. For example, I think repos is like the worst for us, because when people are going and looking for repos, they are looking across millions of public repos and potentially millions or maybe thousands of private repos as well, depending on what they have access to. So it's a lot.
And how this is organized in your indices? So we have like one big index that has the whole thing, or you have multiple indices, and why create one, or if you have multiple, why do you create
Yeah.
multiple indices?
Yeah, actually, so I almost wish it was one index at some points, because my like, if I could see GitHub search move in one way that I would really love to see, it would be GitHub search be unified. I think this is the frustrating bit is, people that are using GitHub search, you go and search and like, oh, okay, I'm searching through repos right now. I need to go click on issue. I feel like that's a terrible user experience. That's not how people search. People expect to type in the search bar and get just results that they want. So right now it is like pretty much as you see on the side of the search bar in GitHub is the way that it is in our indexes. So we have a repos index, we have an issues index, we have a PRs index, and so all of them are logically separated there. But that makes it challenging because, eventually if we want to merge all these results and say, hey, I searched one thing, now I've got to now I'm normalizing scores across all these different result sets, which takes machine learning expertise, which I'm trying to build for myself, because I'm like, I need these tools in my belt to be able to build the better search.
Yeah, and since you mentioned the machine learning, do you think that the CPU is enough for like use cases like this? I think Elasticsearch does not have the GPU yet. I think OpenSearch they started like having something
Yeah,
like that. But
actually, that's a great question. I think a
I,
lot of
I mean, even for the embedding models, I think up until now, the whole thing was is on CPU. The machine learning nodes are only.
yeah.
I think there's something on the roadmap, but I'm not sure.
Yeah, that is as far as like Yeah, generating the embeddings within Elasticsearch, which yeah, is not necessarily how we do things right now. Right now,
You can do it outside there.
yeah, we have outside models and stuff like that. And I think actually, if I was to like recommend, how to do it for a lot of things, yeah, learning to rank, yeah, I think a lot of that has to be done on cluster, but there are a lot of different workflows that you could do outside the cluster that could run on a GPU. Like when I was talking about the clickstream logs earlier, I think that's like a perfect example of like doing analysis on the clickstream log outside of the cluster and building, like synonym graphs or, why am I blanking on words again? The semantic triples, that's what it is. Doing a lot of these things could happen off your cluster on a like dedicated workflow, on a dedicated platform. That's the word I'm looking for. And then you can import the insights.
So basically what you're saying is let the cluster focus on its inverted index, and probably it's I mean in this is vectors in RAM, and the other things you gotta do them outside.
Yeah, exactly.
Yeah, that's interesting. If I wanted to ask you from your experiences with search, and you have a very extensive experience in that, if you wanted to give me like a blueprint that I would apply on any search projects that I need to check to make sure that they're doing the right thing, what would that be?
Oh man, I've been thinking about this so much. This is so funny. You've just hit a recent focus of mine. I have this idea where I think that everything should first be measurable. Then you should understand the parameters that you can tune to get different results. Once you have those parameters, you should be able to test those parameters, and then you should be able to deploy those parameters. So what I mean by this is this is the way that I'm trying to approach search right now. Is I think we need a really good way to score and understand how good or bad search is. And that could be a lot of different things, but you need metrics to measure that. So like number one, does your search have metrics? Do you understand it? Do you understand what your users want? Number two, excuse me, do you know how you can, change that? Whether that is, maybe it is adding vectors. Maybe it is, there are a lot of different ways to query a single text field within Elasticsearch, whether that is, like a match phrase or, these things. So these are all parameters to get different results out. So do you know those? And then a way to test with them. This could be like A/B testing. Actually, I think GitHub's really nice in the sense that, we have this mantra of ship to learn. It is hugely helpful because we have really great testing libraries. We have even like scientific, integrations that allows us to do some like really cool testing. Even as far as like dark shipping things to certain percentage of users. So can you test it? And then once you can test it, can you get it to production? Do you know how you can deploy it? So this is my like working idea of how to get into search. Now, of course, at some point you just need to start. And this is where I'm like, if you're in Postgres, use the PG vector, like go for it. I mean, at the end of the day, you just need to get started. But that is how I would approach search if I was like starting.
Okay. So that's for a project that you're building from scratch. So you say that you need to know to be able to measure your outcome, to be able to define what's controlling that outcome, and to be able to test the fine tuning of the outcome.
Yeah.
So what I would infer is, if you have an existing project, you should be able at first to diagnose what's wrong, be able to know the success criteria of the fix, and then how you test the fix. Is that correct?
Yeah, I think that's a perfect understanding. Just like can you measure? And I think this is also where it gets challenging with vector search, because a lot of people come in and they think, oh, vector search has fixed our search experience. Can you measure it? Do you know? Because if you can't measure it, then you can't actually say that it's fixed, made it better. How much better? Is it 10 times better? Does it cost 10 times more? These are the questions I'd like to see a lot of people answering.
Yeah, that's very interesting, because like it brings to the table that search is an overlap of scientific, technical, but also analytical. You should be able to analyze what is done using algorithms of math deployed technically on something else. That's very. I think that's a very interesting way to look at it. And do you think that people are aware of this?
I don't think anyone knows this. And actually, I think this is the biggest challenge, and why search engineering hasn't like taken off as a discipline is because people treat search as a database. They treat it as a database. I put in a query, I get out results. That's a database. But really, it's a tuning. It is a tweaking. It is a measuring. It is so much more than that. So yeah, search is much more than a database. It's information retrieval, which is incredibly challenging to master.
I think it all comes down to what you have said at the beginning. People should be aware of the value that is added. And you need to convince the developers, but also the stakeholders of the value that they're bringing in. And it all comes down to the metrics and the KPIs that you can drive from this. What about the communities of search? Do you see like any adoption? I know that there are a lot of communities like of Elasticsearch and OpenSearch, but I feel like they are more around the other functionalities that look fancy and easier to test. Will search is something that would like require technically a bit, or that is more nerdy, if I wanted to put it that way?
Yeah, no, I think there are a lot of really good communities there. What I'd probably like to see more of is more like cross-community collaboration. I know like a lot of times I see OpenSearch in its own their own community. I see Elasticsearch in their own community. So like I'd like to see much more work like across the board, which some of it what is that?
Haystack?
The people that do Haystack, I've just lost their name. Open Source Connections. Open Source Connections has done a lot of this work where they've rolled out user behavior insights, which I'm like working with Elastic. I want them to adopt it. I'm badgering them like, hey, which actually I do think they just rolled out integration for UBI, which is the User Behavior Insights Library. But that is the type of work that I want to see, like cross-cutting, such that we can all use like a standard for like clickstream logging. And then, whether we're on Elasticsearch, whether we're on OpenSearch, whether we are, Vespa, Weaviate, we can use that.
I mean, I wish I had another hour with you. I have a lot of questions in my mind, but obviously we already hit the 1 hour here. Are you going to host or be in any event very soon, or something that people should be aware of? Or if you have any blog? I remember you started something, but I don't know if you still keep in.
I have a podcast that I've not spent a lot of time on. We've had a lot of like family health stuff, and actually I'm expecting a child in March.
Congratulations.
So it's our third. So you probably can expect very little from me in the next couple months, but I'm hopefully I'll be putting out a blog here soon about some Elasticsearch interviewing tips.
Probably we should do another session next year. Namely, if you have like the vector search deployed somewhere.
Once I can figure it out,
yeah. All right, David. Do you have any last words for us? 2025. This is the last session of my podcast.
Last session of 2025. Hire a search engineer and trust the answers that they give you. That is my advice.
Thank you very much. Thank you very much for being with us today and for your precious time.
And
thank you very much, everyone, for watching.